All right, our first function is our linear function. Equation is y equals x, or f of x equals x. Our domain and range are both all real numbers. It has odd symmetry. It is not bound above or below. There are no asymptotes or discontinuities or extrema. And it is increasing on its entire domain from negative infinity to positive infinity.
Okay, so we're going to be examining the properties of y equals x squared. The domain value, or x values of this function, go from negative infinity to infinity. Any x values are possible. The range, or y values, go from 0 to infinity. There are no removable discontinuities with this equation, but there are no values below y equals 0. It is bounded from below and no y values below y equals 0. Its symmetry is even. You can fold it over onto itself. The function is decreasing from x values negative infinity to 0, and it increases from x values 0 to infinity. It does have one extrema, a local minimum at 0 at 0. It does not have any vertical asymptotes, but it does have a horizontal asymptote at y equals 0.
Alright, this is y equals x cubed. The domain is negative infinity to positive infinity. The continuity is continuous. The boundedness is above and below because it goes from negative infinity to positive infinity. Symmetry, when you plug in negative x into the original equation, it turns out odd, so the symmetry is odd. There's nothing decreasing. Increasing goes from negative infinity to positive infinity, and it curves a little bit at 0. There are no extrema or asymptotes. The range is negative infinity to positive infinity, and the limit of f of x as x approaches infinity is infinity, and the limit of f of x as x approaches negative infinity is negative infinity.
My function is y equals 1 over x. The domain is negative infinity to infinity with a hole at 0. The range is negative infinity to infinity with a hole at 0 as well. And the continuity, there's a disruption at 0. And it is bounded by its domain. The symmetry is odd. And the graph is decreasing. There are no extremas, and there's a non-removable hole at x equals 0, and there's a non-removable hole at y equals 0. The end behavior of the graph forever gets smaller and smaller, but will never hit 0.
This is the square root function. The domain is 0 to positive infinity. It has no continuity because the graph starts at 0. The equation is not bounded. When you put a negative x value into the equation, the result is not the same or opposite, so there is no symmetry. At no point in the graph is the function decreasing. Instead, it is increasing from 0 to positive infinity. There are no extreme vertical or horizontal asymptotes. The limit of f of x as x approaches infinity is infinity. The limit of f of x as x approaches negative infinity does not exist.
This is the exponential function, and the domain is negative infinity to infinity, and the range is 0 to infinity. It is continuous at all x and bounded below. It has no symmetry, and there's no decreasing, and it's increasing from negative infinity to infinity. There's no extrema, no vertical asymptote, a horizontal asymptote at y equals 0, and the limit of f of x as it approaches 0 is infinity, and the limit of f of x as it approaches negative infinity is 0.
The natural logarithm. The domain goes all the way from 0 to infinity. The range is from negative infinity to infinity. The continuity is continuous when x is greater than 0. Boundedness not bounded. It is neither even nor odd. It is never decreasing, and it is increasing from 0 to infinity. There are no extremas. The vertical asymptote is x equals 0. There is no horizontal asymptote, and the end behavior is the limit of f of x. As x approaches infinity, y goes to positive, y goes to infinity. And as x approaches negative infinity, y approaches negative infinity.
This is for y is equals sine of x. The domain is negative infinity to infinity. The range is -1 to 1. The continuity is continuous. The boundedness is it's bounded at the top and bottom. The symmetry is it's odd. And the decreasing and increasing is oscillating. The extrema is absolute max of 1 at x equals pi over 2 plus 2 pi k, where k is an element of all real or all integers. The absolute min of -1 at 3 pi over 2 plus 2 pi k, where k is an element of all integers. There's no vertical or horizontal asymptote, and the end behavior doesn't exist. For cosine, y equals cosine of x, the domain is negative infinity to infinity. The range is -1 to 1. The continuity is continuous. Boundedness is it's bounded at top and bottom. Symmetry is it's even. Decreasing and increasing is oscillating. Absolute max of 1 at x equals 0 plus 2 pi k. And absolute min of -1 at x equals pi plus 2 pi k, where k is an element of integers. No vertical or horizontal asymptotes, and the end behavior doesn't exist.
All right, next up is our absolute value function. We've got the equation y equals the absolute value of x. The domain is all real numbers. Our range is all values from 0, including 0, and up to infinity, all of our positive values. The symmetry is even. We can see that in our graph by reflecting our graph over the y-axis. We can also verify that with our equation by plugging in the opposite of x. We get the same as our original function back out. It's bounded below, shown by the absolute minimum. We have no asymptotes or discontinuities. It is increasing on all of our positive x values. It is decreasing on all of our negative x values. And it does have that absolute minimum of 0 at x equals 0.
This is a greatest integer function. It's also called a step function or a floor function. The parent function can be written 3 ways. In the calculator is shown as y equals integer of x.
The domain is negative infinity to infinity because you can put any value in for x and get a y value.
The range is all integers. Range is all integers because the y output is the greatest integer less than or equal to x.
The continuity of this function is jump discontinuity at each integer.
This function is unbounded because there is no maximum or minimum y value. There is also no symmetry.
This function is never decreasing, but it is increasing from negative infinity to infinity, and is constant over each step.
There is no extrema because there is no maximum or minimum point.
There are no horizontal or vertical asymptotes.
The end behavior is the limit of f of x as x approaches infinity is infinity. The limit of f of x as x approaches negative infinity is negative infinity.
This is the function f of x equals 1 over 1 plus e minus to the negative x. The domain contains all real numbers, and the range includes all numbers between 0 and 1.
The continuity is continuous. The boundedness is bounded on both top and bottom. The symmetry is neither odd or even.
It never decreases and increases from negative infinity to infinity. The extrema are none because there is no absolute maximum or absolute minimum.
This function has no vertical asymptote. The horizontal asymptote is y equals 0 and y equals 1.
The end behavior is the limit of f of x as x approaches infinity is 1.
As x equals as x approaches negative infinity, the end behavior approaches 0.